Hi, Emily. I just wanted to make a short video of some of your upcoming lessons in ALEX, just to kind of help get you started. So on this first question, it is asking you to write an equation of the line below. So the first thing I like to look at is, do I have a positive or negative slope? And as you can see here, if you can, we have a general decrease. And also, if you can make an N out of the line, you know you have a negative slope. So I just want to make a little reminder for myself, negative slope. So slope is our rate of change, and that's calculated by identifying rise over run, or really just change in y over change in x. So let's go ahead and count that. So 1, 2, 3, 4. Make sure I did that right. 1, 2, 3, 4. 4 over, so that's 4 over 2. So I have a slope of negative 2. So we're going to write the equation in slope-intercept form. So y equals mx plus b. So that's going to be written as y equals negative 2x plus, where b is our y-intercept. In real world terms, it's always a tough one to say. In real world terms, your y-intercept is always your starting point. So let's say you were selling t-shirts and you had to invest $100 before you could start to sell the t-shirts. Your y-intercept would be negative 100. It's the money that's either been spent out at time 0 or just basically your initial starting point. So here our y-intercept, so x is 0, y is negative 3. So y equals negative 2x. Ooh, that is a crazy eraser. Negative 2x minus 3. So that would be an equation for this line. And it never hurts if you want to go back and double check a point. You can. You see this one goes on perfectly, so we could throw in negative 4 and see if we get 5. So negative 2 times negative 4 minus 3, 8 minus 3, yep. So I know I did that correctly. All right, so on this one, we are finding the y-intercept and slope and an equation. So remember in this last problem that we just did, y-intercept is, you're looking at when x is 0, what is y? Because that's where your graph crosses the y-axis. So here we can see when x is 0, y is 8. So we know our y-intercept is 8. As our x's go from 0 to 1 to 2, our y's go from 8 to 7 to 6. So there are two ways you could count your slope here. You could use your slope formula, y2 minus y1 over x2 minus x1. Or since these go down by 1, you know that your rate of change is just going to be what's happening with your y's. So since we're going down, we're going to have a negative 1 slope. But let's go ahead and plug it in just to see. So y2 minus y1, so 6 minus 7 over 2 minus 1. So that gives us negative 1 over 1, so negative 1. So again, our slope is negative 1, so our equation in slope-intercept form, y equals negative x plus 8. And you can always check one ordered pair just to make sure. So negative 1 plus 8 equals 9. So yep, we know we did that correctly. This problem is asking us to state whether or not a function is linear. So if it's linear, you're going to have a constant rate of change. So here we have a set of ordered pairs. So we go to 3, 4, 5 to 6, and then 2, 4, 6, but then we go back to 4. So we have an increase of 2, increase of 2, and now a decrease of 2. So we know not linear. In this problem, we go up by 2, so 5, 7, 9, 11. And so then we go 1 to negative 3, which is plus 4. Negative 3 to negative 6, which is going back down. Oh, wait, hold on. That's 1 minus 4. So 1 minus 4 is negative 3. Negative 3 minus 4 would be not negative 6. But let's just be on the safe side with this one. Let's just check the slope between these 2 points and between these 2 points. So negative 3 minus 1 over 7 minus 5, and negative 7 minus a negative 6 over 11 minus 9. And we can also check the slope between these 2 points. Actually, let's check this first. So negative 4 over 2, which is negative 2. Negative 7 plus 6 is negative 1 over 2. So we can see those are not the same. So again, not linear. Here we go. Let's just check the slope here. So again, y2 minus y1. Oh, actually, what do we have going on here? We have negative 5, negative 5, negative 5, negative 5. So our y value, if we were to graph this, everywhere along that line, our y value is negative 5, no matter where, 2, 3, 4, 5, no matter where x is. So that is linear. It is a horizontal line. And this problem, let's see, negative 1 to 1, that's a plus 2, plus 2, plus 2. So this has a common slope of 2, but let's go ahead and check. 1 minus a negative 1 divided by negative 2 minus a negative 3. So that's 2 over negative 2 plus 3, 2 over 1, which is 2. So 5 minus, I'm going to check another ordered pair. 5 minus 3 is 2. 0 minus a negative 1 is 1, 2. So that is linear. And you could tell by the plus 2, plus 2, plus 2. But always pay attention to what's happening over here. If these aren't consecutive or at least following a pattern, you want to use the slope method. Or you can always plot these on Desmos Grapher just to see if they fall in a straight line. So this question is asking us to find the slope and the y-intercept. My preferred way for doing that is to put it in slope-intercept form, but there are absolutely other ways to do that. You could graph it and calculate the slope from the graph. You could learn a little slope trick, but I'm not a big fan of tricks, so I'm not going to use that method. So let's go ahead and put it in this form. So I just want to get y all by itself. So I'm going to add 9x to both sides. Since 6 and 9x aren't like terms, I just add it on the end here. And then I'm going to divide everything by 3. Thing to remember here is that you have to divide both terms by that 3. So we get y equals negative 2 plus 3x. So our slope, our rate of change is 3, and our y-intercept is negative 2. And that covers, I would say, at least your next 5 or 6 lessons. I've been sending videos out to students that have started in a different cohort just to help them get started. So I hope this helps, and I hope you have a great day. And if you have questions, please feel free to reach out. That's what I'm here for. This is one of my favorite things to do. I know that sounds nerdy, but